Today, I'm going to briefly discuss the slope-intercept form. So, have you ever wondered what does the slope-intercept form looks like? So, we are all familiar with y equals to mx plus b. So, what is that? So, let's break it down. So, b is just basically the slope-intercept, or in other words, it is the y-intercept of this function. So what does y-intercept do to us? So y-intercept tells us that when it touches the y-axis, so that's the y-intercept. And m, we all know that is the slope, which is can be rise over run, right? We already discussed about that. So let's take some example problem on how do we deal with this. So slope-intercept form is basically used for graphing linear function. So if you want to graph linear function easily, we can use the slope-intercept form. So let's say we have a linear function here in standard form. Let's say it's 2x plus y equals to 3. So what we're going to do is just convert this into y equals to mx plus b into slope-intercept form. Am I pronouncing intercept? Intercept. Okay, intercept. Okay, so moving 2x to the right side, we will get negative 2x plus 3. So as we can see here, the slope is going to be negative 2 over 1. The y-intercept is going to be 3. Okay, now, so we can draw a rectangular coordinate plane, and we can plot in the points. We're going to plot in the y-intercept. So that y-intercept will lies in the y-axis, right? Because y-intercept tells us that when it touches the y-axis, we just basically set x equal to 0, and negative 2x cancels out, so we got that y equals to 3. So here, let's make a dot. Okay, now we're going to follow the slope. So slope is just rise over run, and we have a negative sign here, so we will go down twice, right? So let's move twice on the bottom, so we will get a point here. So we just did that. Then we're going to run 1, so that's it. Okay, now let's do it again. Let me put another number here. This is too long. Let me put the number. So we just move down sides 2 times, and then we got 1 here. Okay, so we're going to repeat it until we reach the last point. Our last line in our drawing. This thing continues to infinity, by the way. Okay, so there you have it. This is the graph of this specific linear function. Okay. So this is x and y. Now, if you still don't get it, let's move into other example. So, if we have a linear function such as 3x minus 4y equals to 12, we're just going to transform it into the slope-intercept form if we need to graph it. So, we got 3 over 4x equals to negative 3. Just doing some algebraic manipulation. So now we have our y-intercept, which is negative 3, and our slope is going to be 3 over 4. Now, we're going to draw the rectangular coordinate plane and plot it the y-intercept. So y-intercept is going to be here, around this thing. Let's make a dot there. And let's continue to plot in numbers. Okay, here. So I'm not going to put a number there. I'm just going to put these lines, so we can use the time well. Okay, so let's make a dot here, and then what we're going to do is rise 3, right? Because it's just the slope is rise over run, and then we're going to run 4. So 1, 2, 3, 4. So we got that. So we got this point over here. Now we're going to continue to do it. And we get here 3. And then 4 again. So we got 3 over 4. And this is the another point. So now we can draw our line. So linear function, right? So let's draw a line connecting those things. Okay, let me delete this. So this is our linear function. This thing. So it won't connect because we just ballpoint everything. But we're going to use a calculator, a graphing calculator. This will be the approximate of it. And that's it for this video. I hope you learned something, and goodbye.